Problem is simple. Wikipedia is great. If I want to know about Sundar Pichai or Elon Musk, I get an overview of who they are today. But what if I want to know how they got there? What exact steps, education, job, projects, or turning points led them to their current position? Wikipedia rarely tells them the full journey. Yes, Wikipedia is great, but it's only for the famous. And what if I want to know about someone not globally famous? Maybe a local entrepreneur or researcher or even myself. Wikipedia has nothing. That's where Ozo comes in. Ozo is Wikipedia for everyone. It doesn't just stop who someone is, it shows how they got there from Google search results, LinkedIn, GitHub, Facebook, and then Instagram, whatnot. It scraps all the data. Ozo stitches together a structured timeline of a person's journey. You can literally search your own name or anyone's and see their path mapped out. With Ozo, discovering people isn't just about a summary. It's about understanding the story, the growth, the journey, because knowing where someone is today is useful, but knowing how they reached there is inspiring. Here is one more use case, and I tried to search Pawan Kalyan, and yes, I got the profile. It's a beautiful UI, and all the data sources, like the resources used to fetch this profile, has been listed to the right. And this is a beautiful timeline from birth to death. Everything mapped out very clear.
So try Ozo now and know more about your colleague.
Let's look at the code how we implemented Elasticsearch in this. Yes, Elasticsearch serves as a powerful caching and search optimization layer in this project, dramatically improving performance and user experience. So if we created this store person data asynchronous function where it can by storing previous search person data with a 15-day expiration policy. The system eliminates redundant API calls to external platforms like LinkedIn, Facebook, Google search when users search for the same individuals twice or more than twice. So why it is like that? So we have a multi-orchestrated pipeline where the user is being searched over the internet through API scrapers, link summarizers, and web scrapers, and it collects all the information about the person in raw text and data, then which is used by an LLM to synthesize it in a chronological order, and everything will be pictured here in the data sources, and then cleans it up. This caching mechanism not only reduces response time from several seconds to milliseconds, but also helps manage API rate limits and costs across multiple data sources. The advanced search capabilities of Elasticsearch enable fuzzy matching, partial name searches, and complex filtering across person profiles, timeline events, and professional information, making the application more responsive and cost effective. And then the Gemini, which is the LLM we use to synthesize the data. So it acts as an intelligent brain of the application, transforming raw and unstructured data from various social media platforms into coherent, comprehensive person profiles. It analyzes synthesis information from multiple sources, social media post profiles, professional profiles, as earlier I explained in the pipeline. So gathers all the data, create detailed timelines, extract key achievements, identify relevant professional connections. The AI natural language processing capabilities enables it to understand context, resolve data conflicts between sources, detect potential duplicates, generate meaningful insights about individuals' career progression and personal milestones. And then this intelligent data processing eliminates the need for manual data curation and provide users with rich contextual information that would be impossible to compile manually across dozens of different platforms and data sources. And by this, we are making a good use of Elasticsearch and Gemini services.